All right, one final example that uses an ANOVA. Here, I pulled this from the textbook, and so we're, looking at diets, right? And so the researchers gave some rats access to cafeteria-style diet, where they gave them access to certain foods to study neural and behavioral impacts. Okay, and so they randomly assigned 50 adult male rats to 3 diet groups. Okay, so there's unlimited to rat chow, so like normal rat food. Okay, and then another group had the rat chow unlimited access with an hour of this cafeteria style food, and then the third group had unlimited access to rat chow, and then 18 hours of access to the cafeteria style food. And then um, the data that is provided here is the weight in grams of the rats after a few weeks of study. Okay. And so the researchers are wondering, are the mean weights the same or are they different? Is there evidence of a difference? Okay. Okay, and then so we have to set up the hypotheses, determine if there is a significant difference, and then, statistical evidence, that's fine, and then determine where the differences are. Okay, that's an interesting task. Okay, so let's get going with our hypotheses. Okay, so I'm going to do mu1 is equal to mu2 is equal to mu3. We have 3 groups. Okay, mu1 is the mean weight for rats on rat chow only. Chow. Ooh, oh, my handwriting is terrible. Okay, rat chow only. Mu2, mu3. Mean weight for rats on rat chow plus 1 hour cafeteria food. And then mu3 is mean weight for rats on rat chow plus 18 hours cafeteria food. Okay, and then our alternative is going to be at least one mean mu I is different. Okay, so we have the hypothesis set. We're gonna check. So check ANOVA conditions. Okay, one, do we have SRSs? And let's see, so randomly assigned 50 adult males. Okay, we're going to say yes. It's a little squishy there. You know, each of the 3 groups, are those SRSs of the larger male population? Well, yeah, because they were randomly assigned. And the question is, were the 50, randomly selected in the first place? Well, that we don't know, but we're going to take them at their word because this came from the textbook. The second condition is normality. Okay. Do we have normality satisfied? Again, the prompt doesn't say anything. Weight ends up being a normally distributed characteristic. But if we look at our data, do we have a sample size that's large enough? Not really either. So this one, I would say we're going to roll with it, but this one we would have to come back and maybe do some additional work. Okay, we could make a histogram of each one. Let's maybe just do that quickly. So if we look at insert histogram. Okay, well, let's just see. I mean, are the samples normal-ish, at least upon this initial inspection? Yeah, they all look relatively normal. So I would say it is okay to continue to proceed. If we saw skewness or outliers, then I'd be more concerned. And I could even, change the number of bins to something else. Let's change it. I always like 5. I don't know why I like 5. Change. There we go. Okay. Still kind of normal-ish. Might have to be a little liberal with that definition there. 5. Come on. Come on. Okay. Still relatively normal. Number of bins, change it to 5 just to see. Okay. I mean, even changing the bins, they still see they're roughly normally distributed, at least the samples. So generally, if the sample's normal, that means that they come from a normally distributed population. Okay. So, okay, worry less is what kind of the takeaway is here. And then 3 is, do they come from the same population with standard deviation unknown? Yep. We'll check this, the ratio condition, divide them and see if it's less than 2 when we do our Excel output. Okay. I'm just going to set these all to the side. All right. So now what do? I need to run my test. Okay. Let's see. Data analysis, ANOVA single factor, and highlight the data. Make sure that it's separated by columns in this case. Sometimes it could be in rows. Output range, change that to, I don't know, right there. Okay, so here we go. P-value is small, so we reject the null. I'm just going to check the standard deviations. Okay, so again, these are standard deviations. And I can tell you that if I, at least based on visual inspection, we can do the math, but the standard deviation condition will be satisfied. Okay, yep, we're fine. Still under 2. Okay, but p-value is small, right? So we would reject the null. Okay. So we are going to wrap this thing up and say, okay, here we are. And then since P is approximately 0. Oh gosh, how many zeros? 3 zeros? 1, 2, 3, 1, 5, which is less than any level of significance that we may introduce. We reject the null based on the data. There is sufficient evidence that at least one mean weight is different. Okay. Now, the prompt also said, if there is a difference, determine where that difference might be. Okay. And so to save time on the video, I'm not going to go through the full details here, but let's go back to our Excel data. Okay. And as we look at this, okay, the reason I like this first table is it can provide some insight, mainly because of the averages, right? The sample mean is an unbiased estimator of the population mean. And so if we can get a good idea of where we need to start looking just based on the sample means. If we compare, this was rat chow only, and this other one was rat chow plus cafeteria food, there is a difference there, at least to me when I look at them. So what I would do next is I would do a 2-sample t-test. And I would do a 2-sample t-test between the rat chow only group and the extended access group. So between the outer 2 columns. I might even wager to say there is probably a difference between rat chow and restricted. So I might do a second t-test just to look at that and say, okay, well, if chow is different than extended and chow is different than restricted, there is something going on here. And that would be the introduction to the analysis that I might perform. I might also construct confidence intervals, right? To look at the mean difference and say, okay, well, what is the mean difference between these two? And go from there, okay? So more analysis to come, and this in a data set even as large as this with multiple groups, it does take some time to analyze. Okay, so don't be surprised if you're spending a lot of time later in your life with complex data sets.